Hello everyone, today we're going to be talking about graphing radical functions. So first for some vocabulary, a radical function is a function that contains a radical expression where the independent variable x is in the radicand. So that means that the x is underneath the radical, whether that's square root or cube root, fourth root, and so on. We're going to be talking about two different functions today. The square root function is when the radical is a square root. And the cube root function is when the radical is a cube root. So the parent functions of both of those, for the square root function, the parent function is f of x is equal to the square root of x. And we see the graph of that square root function here. Something to notice is that the domain and range are x is greater than or equal to 0 and y is greater than or equal to 0. And that is because we can't have a negative underneath that square root. So we learned in a previous unit when we have a negative underneath the square root, that leads us to having imaginary numbers, which do not show up in our real number graph here. So because of that, when we have the square root, the domain has to be and range have to be positive. And remember, domain is all your x values and range is all your y values. So for instance, if this graph was instead up here and going that direction, the domain would still be x is greater than or equal to 0 because on the x-axis it's going from everything from 0 on. But my range here would instead be y is greater than or equal to 2 because I'm looking at 2 on the y-axis and it goes everything above that. So something to watch out for when you're going into that homework assignment. And then the cube root function, the parent function for that is f of x is equal to the cube root of x. And we see the graph of the parent function here. Here, since we can have a negative as our x value underneath that cube root, the domain and range will always be all real numbers because this is going to cover all of the y-axis and all of the x-axis. So let's go through some practice of graphing these radical functions. So for this first one, I have f of x is equal to the square root of 1/4 x. So to do this, I'm going to go ahead and make a table for these values to sketch the graph. And remember with square root, the domain has to be and range have to be positive. So I can't put any negative x values in here. So if I put a negative x value, that's going to make this taking the square root of a negative number, which doesn't give us any real numbers. So that gives us imaginary. So my smallest x value can be 0, so I can plug in 0. And then I'm going to go ahead and just to make my life easier, I'm going to do everything that can easily be divided by 4. So I'm going to do 4 next, and then 8. So plugging those in, I have the square root of 1/4 times 0, which is equal to the square root of 0, which is just 0. So that's my first point, is at 0, 0. Next one, I have 1/4 times 4. Well, 1/4 times 4 is just 1, so the square root of 1, which is equal to 1. So my next point is at 4, 1. So I'm going to go to the right 4, up 1. And then plugging in 8 into my function, I have 1/4 times 8, which is equal to the square root of 2. And the square root of 2 is equal to 1.41, which you can enter that into your calculator. So I'm going to go to 8, and I'm going to go approximately up 1.41. And so that gives me this as my graph. Then it asks to identify the domain and range. So domain, remember that is all x values. So looking here, I see it starts at x equals 0, and it covers everything to the right of it. So that means the domain here is x is greater than or equal to 0. The range, all my y values, And here it starts at y is equal to 0 on the y-axis, and it goes everything up. So the main range here is y is greater than or equal to 0. Now for number 2, it says to graph g of x is equal to -3 times the cubed root of x. So this time we have a cube root, so we can have negative values in there. So when I'm making my table, with the cubed root, I like to go ahead and just go with the values of -2, -1, 0, 1, and 2. And so plugging those in, I have -3 times the cubed root of -2. And when you enter that in your calculator, you should get 3.78. And then -3 times the cubed root of -1. And when you plug that in, you should get 3. Plugging in 0, you get 0. And then we'll see when we do the positive values, you'll get the same number, but just the opposite sign. So now this time when you plug in 1, you get -3. And when you plug in 2, you get -3.78. And so applying those points, at -2, we go up 3.78. So somewhere around here. -1, we are, I'm sorry, that was at -3. At -1, we are at 3. Then 0, we're at 0. 1, -3. And 2, -3.78. And so our graph will look something like this. Since this is a cube root, we know that domain and range here is just going to be all real numbers.